All right, the next symmetry element that we're going to be talking about is that of reflections. And we deal with reflections quite a lot in our active life, but how do they actually come out and be useful when we're thinking about them in chemical terms? So, when we're thinking about reflection symmetry, what we're actually recognizing is that the molecules have a plane of symmetry. And planes of symmetry are identified as symmetry elements with the letter sigma. So, we'll talk about sigma planes quite frequently in this video. So let's go back to our good old friend water here, where again, we're going to look at water from face on. And I've drawn my mirror plane here at the center. So what we recognize is if I do a reflection and like this is a mirror, everything is going to look reflected from this side over to this side. So now 2 becomes 1, 1 becomes 2 like we've got over here. So again, we see that nothing has changed by doing a reflection across that plane. The harder one to see, or one that's less obvious to us when we first glance at it, is if we rotate our molecule. So now we're looking at this view of the molecule. We still have a reflection plane because I can take all of this, reflect it over to here, and we get this molecule. It looks the same. So here are 2 unique reflection planes here. And we are going to identify these with V's. They are referred to as vertical. How about vertical mirror planes? And vertical mirror planes will connect, tongue-tied today, will contain the principal axis of the molecule. So remember, we could think about this having a C2 rotational axis to it, where we would swap those 2 through a rotation. So the mirror plane is here. It contains that mirror axis in that principal axis. So therefore, we have a vertical mirror plane here. So obviously, if I'm talking about vertical mirror planes, there must be other types, but let's look at it in a different way. So for example, here I'm showing you where my principal axis is, and then I've drawn a 3-dimensional grid around that so we can see different planes. So the red planes that we're showing here are outlining the different mirror planes. So here is one of them, and here is a second one in this set. So for example, here I'm reflecting from the back to the front. Here I'm reflecting from the side to the side. So those are 2 different sigma V planes of this system here. Big thing here is that it contains the principal axis. So if we don't contain the principal axis, what do we have? Well, this is what we would call a horizontal mirror plane. So a sigma H group here. So here, again, we've got our principal axis in the same orientation running up and down here. And now my plane is going and bisecting that. So it's going perpendicular to the principal axis. That's the big identifier, being perpendicular to the principal axis. That gets us our sigma H plane. So those 2, I think for most people, are pretty relatively easy to spot in molecules. There is one more, however. The last one is called a sigma D, or the dihedral symmetry plane here that we have here. And this is one that contains the principal axis, but it also bisects the angle between 2 of the C2 axes. So this is something that can be a lot harder to see, so we'll have to spot it and identify it in multiple cases here. I'm showing it down here, and you can kind of see how it is different. It does still contain the principal axis, but it may not be easy to see how it's bisecting 2 C2 axes. So let's point that out in another grid over here. So let's look over if we have something that has hexagonal symmetry here. So our principal axis is down. We're looking down that principal axis now. If we look at this molecule, what we could have is here we have a sigma V plane here. And also, if we look, we would have a C2 axis, a C2 axis. We'd have a C2 axis over here, a C2 axis here, 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 here. You're getting the point here. There's a lot of C2 axis in a hexagonal symmetry case. But what we notice here is the sigma D here, it goes between two C2 axes. That's what it is. This will get a lot easier to see once we start doing some examples. Here, when we're just doing some basic geometry, it's a little bit goofy to conceive of. But don't worry, we'll get to some actual examples. The big key thing here to take away from here is how do you identify these when we see them? Does it just contain the principal axis? Does it act perpendicular to the axis? Does it contain and bisect two C2 axes? Those are the distinguishing characteristics that we're going to have to use. All right. So again, we're just talking through the elements now. We're going to start applying them in some examples in another video here. So hold on to these. Basically, this is basic definition level. All right. So that's it for the mirror planes. We'll talk about the last symmetry element in the next video. And until I see you next time, be excellent to each other.